Graph to solve systems. So a system of two linear equations describes a relationship between two lines in a system. And we use these systems graphically to determine if the lines intersect at one point, or if they're parallel and they don't share any points, or if they're exactly the same line and every point on the line is in common between the two lines because they're the same. So we use linear systems quite often when we're working with unknown numbers for geometry problems, distance problems, work problems, and mixture problems. We'll use systems quite often to help us solve them. So first we want to just look at what do they look like when you work with a system and graph it. So I want to show you a couple examples. This first one, y equals x minus 6. I want to think about my slope. I want to pull that off. Remember, that's the coefficient of the x, and if nothing's there, there's an implied 1. So my slope is 1. I can think of it as 1 over 1, and I can also multiply by negative 1 over itself and think of it as negative 1 over negative 1. And then my b, which is part of my y-intercept, is a negative 6. And that means 0, negative 6 is my y-intercept. So 0 in the x direction, let me change colors so we can see it. 0 in the x direction, 1, 2, 3, 4, 5, 6, all the way down to right there. That's 0, negative 6. Now I can use my slope, which is a negative 1 over negative 1, or I could use the positive 1 over positive 1 first. So I'll do the positive 1, that means a rise of 1, a run of 1, puts me right there. And back to my original point, a rise of negative 1, a run of negative 1 puts me right there. Now if I go to graph this and make a line, it's going to look something like this with an arrow on each end. Now that was my first line in the system. We show systems with this nice little squiggly or curly brace there, and that tells us we're dealing with a system. So let's look at the second line in our system. This one has a slope of negative 1. I can see it because of that negative in front of the x. So my slope is negative 1. Think of it as a fraction. And then remember, multiply by negative 1 over itself. So I have a positive 1 over negative 1 for my alternate view of the slope. And then my b is a negative 2. And I can see that right here. And that means my y-intercept is 0, negative 2. So I'll go 0, negative 1, negative 2 right there for my y-intercept. And then I have a slope, first slope of negative 1 over 1. So rise of negative 1, run of a positive 1. And I can carry that out a little more because I see right there's my intersection point. And then back to my original y-intercept, and I need to go from there, a positive 1 for the rise, that's up 1, and a negative 1 for the run, that puts me over here. So when I graph this line, we can see the intersection point, if we can see nothing else, and it is at the point 1, 2, 1, 2, 3, 4. So the intersection is at 2, negative 4. And what that means is that that is the solution to our system. So these two equations, we can graph each line, look for the intersection point, and that is the solution to the system. And since they do cross, we expected to see that. Let's look at another example. Here we have 1/2 x minus 1, so that means my slope is 1/2. And my alternate view of looking at it is negative 1 over negative 2. I'm hoping you're getting used to figuring that one out. And then my b is a negative 1, and the ordered pair for it is going to be 0, negative 1. And that is my y-intercept at 0, negative 1, right there. And then I can use my slope, one form of it, rise of 1, run of 2, puts me right here. And back to my y-intercept, a rise of negative 1, run of negative 2 puts me right there. There's that line. I'm not sure where the other one's going to intersect, so I wanted to make it nice and large so I could see it. next line that I need to graph in this system, I have 5/6x, so my m is 5/6. And I have another way of looking at that, -5 over -6. That gives me two views. And my b is the +1 right there. Remember, this is the y = mx plus b form, and so the b is a +1, which means my y-intercept is 0, +1. And then I'll plot that. 0, 1 puts me right here, and my slope is +5 over +6. So rise of 5, 1, 2, 3, 4, 5. Run of 6, 1, 2, 3, 4, 5, 6. Back to my y-intercept, a rise of -5, 1, 2, 3, 4, 5. A run of -6, 1, 2, 3, 4, 5, 6. And that puts me right on my other line, which is handy because I wasn't sure exactly where they were going to cross. Put an arrow on each end there, and I can see my intersection point is right there. And that is 1, 2, 3, 4, 5, 6. So -6. And then I went down 1, 2, 3, 4, -4. So my intersection point is at -6, -4.